Hello students, welcome back. So in this session, we are going to be studying containers for data. So the main one that we'll be studying would be list, tuple, and set. So let's start with the list first. A list is an ordered, mutable collection of elements. When I say ordered, it means that the elements in the collection, they maintain the order in which they were inserted. In other words, they were added. List, they can also contain duplicates. Lists are heterogeneous. In other words, they can contain elements of different data type. For example, it can contain integer, string, boolean, and so on and so forth. List, it supports indexing and slicing. For example, you can access an element by zero like this, by indexing. You can access a list of a range of numbers by 1 colon 3. So this is called slicing. Some of the use cases of list is when you need to preserve order of elements, when your collection will change very frequently. If you know you'll be doing a lot of insert operation, update operation, delete operation in your data, you want to use list. Lists generally they tend to be very good for general purpose storage and for data manipulation. Now let's focus on tuple. A tuple is an ordered immutable collection of elements. In list it was ordered and mutable, here it is immutable. Tuple, they can contain duplicates, and also they are heterogeneous. Same thing, in other words, they can contain elements of different data type like integer, string, boolean. Tuple, they also support indexing, they also support slicing. Tuples, they are slightly faster than list, and they are good, they're ideal when your data remains fixed. In other words, when you do not have to perform many insert or update operations. That's when you want to prefer tuple over list. Use cases of tuple, when you want to create a constant data structure. Often tuples are used for read-only or hashable data. For example, keys in dictionary. Tuples, they tend to be ideal when your data are not or is not changing very frequently. And also you want to make sure that if your data does not change accidentally, then you want to use tuple. And then you have sets. A set is an unordered, mutable collection of elements. A set, it can contain no duplicates. Your list and tuple, it can contain duplicates. A set, it can contain elements of different data type, as long as the elements are string, integer, float, or boolean. A set, it cannot contain list or dictionary. A set does not support indexing or slicing. On the other hand, list and tuple, they do support indexing and slicing. Use cases of a set is when you need to eliminate duplicates. Very handy. When you're doing set operations like union, intersection, differences, you use set over there. When you need to check for membership, for example, if you want to check if some element X is inside some set, so they tend to be very fast lookup. So this is a short summary of what we have covered. Ordered, list is yes, tuple is yes, set is no. Mutable, list is yes, tuple is no, and set is yes. Allows duplicate, list is yes, tuple is yes, and set is no. Indexable, list is yes, tuple is yes, and set is no. And use cases, general purpose, fixed data, and for unique elements. In this case, your data can be changed. These are hashable use cases, and they tend to be for fast lookups. Okay, so how do you create list, tuple, and set? Well, the way you create a list is by using the square bracket. For tuples, you use round bracket, and for sets, you use curly braces. So suppose I want to create a list of elements, a list of elements that contains names of people. So in this case, these are the names: Tom, Ashwani, Patel, Shamlodia, Ashwani, Tom, Ashwani. In this case, I print my names and I also print the type. So let's run this, and you can see that it prints out this in exactly the same way it was written over here. So I created a list like this, and this list has been printed in exactly the same way it was created. In other words, your output, it preserves the order. Your Tom Ashwani Patel was like this, and Tom Ashwani Patel. So the order in which it was created is the same order in which it is printed. It can also contain duplicates. You can see that there is a Ashwani over here, Tom over here, and Tom over here. And you can see that Tom and Tom and Ashwani, Ashwani. And I'm also printing the type. In this case, it's a class list. So with this square bracket, that signifies list. Let's look at tuple. Tuple, it preserves the order, and it can also contain duplicates just like list can. The only difference between this and this, now I'm using a round bracket over here. That's it. Elements are same. Everything is same. So in this case, I'm printing names and I'm printing type. And this prints out your tuple right here. As you can see, the order is same. So the order in which I created this tuple is printed in exactly the same order right here. I'm also printing the type, and you can see it's a class tuple. Okay, now let's look at sets. So in this case, my set contains exactly the same elements that was these elements right here. But your duplicates would be removed in this instance. So when I run this, you can see that after I create these set of names like Tom is being repeated inside, Tom is repeated, Ashwani is repeated, Ashwani is repeated. But when I print my names, you can see that Tom is being only printed once and Ashwani is only printed once. And that's because that's one of the characteristic of set is that it is going to remove duplicates. Very handy for that, if you want to remove duplicates. If you want to see what type that is, in this case, this is you run this command and that's going to give you it's a class set. So sets are created using curly braces right here. Okay, now the set, it does not preserve the order. So for example, let's say I create a set of Tom, Ashwani, Patel, Shamlodia, Jambosh, and I print my name. Now when I run this, you can see that your output is not in exactly written the same way in which it was printed over here. If you can see that it was Tom first, Ashwani next, and then Patel, and look at that, it's Ashwani first, Jambosh, Shamlodia, Patel, Tom. So it does not preserve the order. Now, a list is heterogeneous. What it means is that a list, it can contain elements of different types, different data types. For example, it can contain integer, float, list, tuple, and set, and so on and so forth. For example, let's take a look at this list right here. I'm creating a list. I'm inserting an element in it, 1. That's an element 1, which is integer. I'm also putting 3.2, that is a float. I'm also putting a list inside. So list is containing another list inside. And this list has integer, integer, and a string over here. Then inside the same list, right here inside my L, I'm also putting a tuple. Tuple contains 134, which is an integer. I'm also putting a set inside. So you can see that it has an integer, it has a float, it has a list, it has, I can put all the stuff over there. I can even put another boolean. I can put like true over there, true, and that's going to work just fine. So if I run this, it's going to print out my list over here. All right. In this case, uh, tuple is also heterogeneous. It can also contain elements of different types. The same thing. In this case, my tuple started with a round bracket, ending with a round bracket. It contains an integer, contains a float, contains a list, okay, contains a tuple, and also contains a set. And let's put a little boolean in there. Just throw a boolean in the mix. True. And when I run this, it's gonna print out your tuple right there. This is exactly the same tuple right here. A set, it can contain you can have a set of integer, float, boolean, string, but you cannot create set of list and set. For example, in this case, I'm creating a set that has an integer, it has a float, it has a boolean, it has a string, it also has another string, and two boolean values. When I run this, it prints out everything fine. Now if you notice, the order is not preserved. Another thing you notice that your true, there are two true values and one of them is gone because set does not allow duplicates. By the way, you cannot have set of list and set. So if I run this, it's gonna throw an error. And there you go, an error, because this is a list. The set does not allow set of list or it does not allow set of set either. All right. And now, how do you access elements of list and tuple? Well, list and tuple, they support indexing. That's a good thing. So the way you access a list is by specifying your index, and you use this square bracket right here. So suppose I have my data right here, and this is a list of numbers. This could be anything. This could be age, income, could be anything. And by the way, on a side note, your index always starts with 0. So this is index 0, this is index 1, this is index 2, index 3, and so on and so forth. So if I want to access an element at index 0, I'm going to use data, square bracket, put 0 over there, and close the square bracket. And when I run this, let me comment these two lines out. Okay, let me comment all these lines out, and let's just use this one. So when I run this, it's going to print 10 because the element at index 0 is 10. What if I want to print an element at index 3? Index 3 would be 0, 1, 2, 3. This is the element at index 3. When I run this, it's going to print 70. All right. What if I want to have element which is the last element? You can access the last element too by specifying -1. So this will be -1, this will be -2, this will be -3, -4, and so on and so forth. So if I type print data -1, that's going to print me the last element, which is 50. 50. What if I want an element, fourth element from the last number? So this is -1, -2, -3, and this is -4. I want this one. So you just have to say data square bracket -4. This is called indexing, and it prints out element at which is the fourth element from the last. Then there is a list slicing. Uh, the way your list slicing works is that you open up a square bracket, you specify your starting index, and then there's a colon. Then you specify your stop index, then there's a colon, and then you specify your step size. If you do not specify any one of these position, then by default, your start index is going to be 0. Your default for stop index is going to be the last position of your data of your list or tuple, and your default for your step size is always going to be equal to 1 if you do not specify any of these values. Again, let's say this is your data right here, and you print my data, and I print the data right here. So it prints out the data. So let me comment this line out, and let's run this. So what's just happening is this. I'm saying 1 colon 5. Well, actually, it's going to print out all the element from index 1 to index 4. It is not going to print the index 5th. It's going to print all the way up to index 5, but excluding 5. So it's going to slice from index 1 to index 4. So the element from index 1 would be this, index 2, index 3, index 4, right here. So it's going to print 30, 60, 70, and 50. 30, 60, 70, 50. If I say, if I write 7 over here, it's going to print, actually, let's just make it 2. If I say 2 colon 7, it's going to start with index 2, 3, 4, 5, and 6. It's going to print these elements. So if I run this, you can see that it printed 60, 70, 50, 30, 60. All right, let's go back, change it to 5. Let's run this, and there you go. Now let's look at this step size right here. Here I did not specify this right here. I just used only 1 colon 5. So by default, your step size was 1. But now let's change the gear a little bit. Let's specify our step size. So I'm saying slice from index 1 all the way to index 7, okay? But do not include index 7. In other words, you print index 1, 2, 3, 4, 5, 6, but this time you use step size of 2. So in other words, you're just going to skip one of the elements. So you keep going one over the other. So when I run this, it's going to print 30, 70, 30. So start with index 1, which is right here. Step size is 2, so it's going to go 1 and 2. Let me just use this marker. It's a little bit more easy to understand. So it's going to start with this right here. This is my index 1, and step size is 2. So it's going to go 1, 2. It's going to print 70. It printed 30, printed 70. Then it's going to go 1, 2. It's going to print 30. It printed 30. Now it's going to keep doing it until it reaches index 7, but it's going to exclude 7. So it's going to stop 1 before 7. That would be index 6. So your index 6 would be 0, 1, 2, 3, 4, 5, 6. This is where it's going to stop. So it's going to go again 1, 2, 1, 2, and then 1, 2. It cannot go further than that. So it's only going to print 30, 70, and 30. Okay. Uh, List slicing. Let's play around with list slicing a little bit more. So suppose I have this data right here: 10, 30, 60, 70, 50, 30, 60, 90, like this. I want to slice the first 3 elements. Well, in this case, you can say data colon 3, and this is going to work just fine. Let me comment these lines out right here, and let's run this. It's going to do. Oops, sorry, where was that? Ah, there it is. Was it this one? Nope, 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 nope. Oh yeah, there you go. So I want the first slice of the first 3 elements. So you just say colon 3. You don't have to specify 0. It's because by default, if you're not specifying, your start index is going to be 0 by default. So it's going to print out element from 0, 1, and 2, the first three elements right here, 10, 30, 60. All right, what if you want slice of elements from index 2 all the way up to the last element? So in this case, I'm not specifying this element. In other words, I'm not specifying stop index, and I'm also not specifying my step size. So default for your stop index is going to be last position, and your step size default is going to be 1. So it's going to go from starting with index 2, okay, and it's going to keep going all the way to the end. So index 2 would be this right here. So it's going to go from here all the way up to here. It's going to print this. When I run this, you can see there 60, 70, 50, 30, 60, all the way up to 50. All right, what about this? In this particular instance, I'm saying print everything, give me all the slice from beginning all the way to end with the step size 2. So in this case, I'm not specifying this. My start index, I'm not specifying. So by default is 0. That means start with index 0. Stop index, I did not specify over there. So since I did not specify, my stop index is going to be the last position. So start from the beginning all the way to the last position. Step size is 2. Okay, and when I run this, it's gonna print out, well, let's see, let's just, before I run this, let me just show you what it does. It starts with here, okay, step size 2, so 1, 2, it's gonna print 60, it's gonna go 1, 2, because my step size is 2, gonna print 50, 1, 2, gonna print this, 1, 2, and it's gonna print this. It's gonna print 10, 60, 50, 30, and 10. And let's run this. And let me just comment this out and run this, and there you go. 10, 60, 50, 60, 10. 10, 60, 50, 60, 10. All right, what if you want to reverse the string? Well, you can reverse that too by using -1 over here. So your start index is 0, your end index is -1, and you're saying go in a negative direction. Step size is -1. You can do that. So this is a little nifty trick. If you have to reverse the string, you can do that using this little -1 at the end. This is going to print 50, 10, 90, 60. You can see that 50, 10, 90, 60. It's just printing this whole string in a reverse order. Same thing with tuple. Whatever we did this thing for list, we can do the same thing with tuple. In tuple, indexing starts with 0. So I create a tuple right here. And these are like anything. This could be anything. This could be, let's say, age or income. I print the data. And let's say you want, let me just comment these two lines out. Let's run this. If I want an element at index 0, you say data, square bracket 0. And it's going to print out element at index 0, which is 10 for the tuple. If you want an element of the tuple at index 3, this is going to print out 70, 0, 1, 2, 3. When I run this, it prints out 70. All right. What if you want to have the last element? Same principle like the way we did with list. Put -1 inside the square bracket. And that's going to give you the last element, which is 50. Double slicing, same principle like the way we did with in the list. Start index, stop index, step size. Default for stop index is 0. Default for stop index is last position, and the default for step size is 1. So in this case, everything is same. I'm just changing my data to 1 to 7, and I'm actually changing my data from list to tuple. That's it. But other than that, everything is same. So when you run this, it's going to print everything exactly the same way the way it did for the list. Slicing, in this case, same thing as we did for the list. This is my tuple right here. So if you want to slice the first three elements, you can say :3, and that's going to give you the first three elements. So when you run this, it's going to print the first three elements: 10, 30, 60, just like it did with the list. Same thing with this. This is going to be printing the slice from index 2 all the way up to the last element. When you run this, it's going to print 10, 70, 50, 30, 60. So it starts from index 2, which is this right here. All right. Same thing with this. If you run this one, this is going to print from beginning to end with a step size 2. Beginning to end with a step size 2, just like we did with the list. And there you go, 10, 60, 50, 60, 10. What about this one? Well, this is going to reverse the string. No surprises here because this is going to follow exactly the same pattern as it did with the string. As it did with the list. And then your set, it does not support indexing the way indexing was supported by list and tuple. So suppose this is my data right here. This data is a set, and I print my data. This is the print right here. Now, if I try to change or if I try to access an element at index 0, I'm going to get an error. And that makes sense because if you look at your element right here, it is not preserving the order. You see that this is not the same as this. That's because it has removed the duplicates, it is changing the order. So that's why indexing does not make sense over here. Let's run this. All right. Now, list and set are mutable. In other words, you can change the elements of list and set. On the other hand, tuples is immutable. You cannot do that to a tuple. So let's understand this through an example. Suppose I have a list right here. I print the list before I make any changes, and then I make a change over here. I'm saying over here that change the data at index 2, which is right here, to 99. And then I'm printing my data again after that. So when I run this, you can see that data before is this right here. And this is your 60 at index 2. After I made the changes, now this is 99. All right, now let's try to modify the same thing, the same data, but this time I'm using a tuple right here. So I print my data right here. Now if I try to modify at element at index 2, just like this one right here, I'm trying to modify that. Let's make this thing as 99. Okay, so if I try to modify it, it's gonna throw me an error. Tuple object does not support item assignment. So tuple is immutable. That's what you mean by this statement. Now set elements, they can be changed, but you cannot change them through indexing because indexing is not allowed. I will explain you later on how to do this thing. Now let's look at these inbuilt function list, tuple, and set. These are used to create or convert collections of data from one type to the other type. Let's convert our tuple to list and set. Suppose my tuple is given by this element right here. And the way you convert into a list by calling this list function. And you supply the argument of the tuple t right here. Likewise, you can convert into set by calling the set function and pass in this t right here. Now, when I print my list, print my s, which is my set, it prints out everything just fine. In this case, you can see that when I print my s, it has removed the duplicates. 2 was getting repeated 3 times. Now it's only 1 time over here in your set. You can change, let's change a list into a tuple and a set. So let's say this is my list right here. And the way you change into tuple by calling the tuple function, pass in your list to that, change into set by passing a list to that, run this, and it's gonna print out your tuple and it's gonna print out your set by removing the duplicates. Let's change set to list and tuple. So this is my set right here, convert into a tuple and convert into a list. So in this case, it creates a T, it creates a L. These are two variables. I print my T, print my L. In other words, print your tuple, print your list. It prints out the tuple right here and it prints out the list.